Good morning, everyone. In this class, we are going to discuss about ocean reliefs and landscapes beneath the waves. Okay, now the 71% of Earth's surface hidden beneath our oceans is not a featureless plain. It contains vast mountain ranges, deep trenches, and expansive plains. These variations in depth and elevation are known as ocean relief or submarine relief. The oceanic crust is geologically young, typically less than 70 million years old. Understanding this relief is essential for explaining plate tectonics. It directly influences global climate, ocean currents, sediment deposition, and biological productivity. Its study is crucial for locating marine resources from fishing grounds to mineral and energy reserves. Okay, this is the mid-oceanic ridge, deep sea trends, abyssal plains, and deep sea plains. Okay, these are some oceanic features, marine features. Okay, now the blueprint of the abyss from coast to deep sea. The relief of the ocean floor is broadly classified into two types: major fissures and minor fissures. Major fissures are large-scale structures forming the foundation of ocean basins, and minor fissures, smaller sedimentary fissures formed by specific tectonic, volcanic, or biological processes. Okay, this is a mnemonic techniques to represent the sequence from coast to the deep sea. SSRA. SSRA, that means shelf, slope, rise, and abyssal plain. Okay, number one, continental shelf, a wide, gentle sloping area extending from the land. Then continental slope, this portion, a much steeper drop off from the edge of the shelf. Continental rise, a gentler slope at the base of the slope, showing accumulated sediment. Then abyssal plains, a vast flat expanse at the bottom of the sea floor. Okay, number one, continental shelf. A gently sloping submerged extension of a continent, the shelf is where land gradually meets the ocean. It accounts for 7.5% of the total ocean surface. Okay, continental shelf, a wide, gently sloping area extending from the land. Types of shelf: glaciated, like example Greenland; coral reef, for example Queensland and Australia; white shelf, Arctic oceans. Okay, key characteristics are slope gentle about 1 degree to or less, and depth up to 200 meters. White averages 70-80 km but can exceed 1,500 km in the Arctic. Okay, there are some economic and ecological importance of this continental shelf. Site of the world's richest fishing grounds, example Grand Banks, North Sea. Major source for oil, gas, and mineral exploration, supports immense marine bird biodiversity. Okay, now the second part is continental slope, this portion, marking the true boundary between continental and oceanic crust. The slope is a steep gradient connecting the shelf to the deep ocean floor. Continental slope, a much steeper drop off from the edge of the shelf. Key characteristics are gradient, steep, averaging 2 degree to 5 degree. Depth range from 200 meter down to 3000 meter. Key features often increases in sizes by vast submarine canyons such as the Hudson Canyon and Monterey Canyon. Significance, it is of significance, like this is the primary zone for sediment transformation from the continental margin to the deep sea regions. Okay, next, coming to a third point, continental rise. Okay, this is the continental rise portion between abyssal plain and continental slope. At the base of the slope, the gradient lessens. Here, sediments carried by powerful turbidity currents accumulate to form the continental rise. Okay, a wide, gentle inlet formed of accumulated sediment at the base of the slope. Okay, key characteristics are slope gradient, gentle, less than 1 degree. Depth range found between 3,000 meter and 4,000 meter. Height can extend up to 600 kilometer. Okay, noteworthy absence, continental rise are often absent near subduction zones where an oceanic trend typically forms instead. Okay, now the next geological features, abyssal plains. Covering nearly 40% of the ocean floor, these deep sea plains are among the flattest and smoothest regions on the planet. Okay, an extensive, incredibly flat region covered in fine sediment. Okay, this is the portion, abyssal plain. Okay, key characteristics: depth lie between 3,000 meter and 6,000 meter. Composition formed from fine grained sediments like clay and silt that blanket the original topography landscape. While incredibly flat, they are interrupted by submarine ridges and isolated volcanic islands. Okay, importance act as a major sediment sink and play a vital role in global heat distribution. Okay, this is abyssal plains. Okay, these are four basic types of continental marine features, marine reliefs. Okay, now the anomalies of deep, exploring the minor relief features. Okay, the vast ocean floor is punctuated by remarkable structures formed by volcanic, tectonic, erosional, and biological processes. These minor features, while smaller in scale than the major divisions, reveal the dynamic process that shape our planet. Okay, features to be explored: mid-oceanic ridge, seamounts and guyotts, oceanic trenches, and coral relief or atolls. Coral reliefs, oceanic trench, guyotts or seamounts, and mid-oceanic ridge. The world's longest mountain range, mid-oceanic ridges. Okay, a continuous underwater mountain chain formed at divergent plate boundaries as plates pull apart, magma rises to create new oceanic crust. Okay, pull apart and magma rises from the astronosphere and creates the mid-oceanic ridge. Okay, key facts: total length 75,000 kilometers, average depth. Summits are typically 2,500 meters below the surface. Geological activity associated with intense volcanic activity, earthquakes and hydrothermal events. Example: the Mid-Atlantic ridge, which passes through Iceland on the surface. Okay, this line indicates the mid-oceanic ridge. This portion, this line, like this. Okay, mid-oceanic ridge system. Now, seamounts and guyotts. These features are isolated volcanic mountains arising from the ocean floor. Their shapes tells a story of their geological history. Seamounts. Okay, this is the seamounts like this, and guyotts. It is plain top. Okay, former sea level. Seamount, volcanic mountains with pointed peaks that do not reach the sea surface. Example: Imperial Seamount, Pacific Ocean. Then guyot, flat-topped seamounts, flat-topped. Their summits were eroded by waves when they were at sea level before subsiding. Example: Bear Seamount in Atlantic Ocean. Okay, it provides crucial habitats for deep sea species and indicate past volcanic activity and crustal movement. Then oceanic trenches. The deepest parts of the ocean, these long, narrow, and steep-sided depressions are formed at subduction zones where one tectonic plate descends beneath another. Okay, one oceanic plate descends another, and like here, this is subduction zone, and in this line, oceanic trenches are created. Okay. Key features associated with intense earthquake activity and volcanic arcs. Depth typically range from 6,000 to over 11,000 meters. Okay, the deepest point, for example, Mariana Trench in Pacific Ocean, depth 11,034 meter. Tonga Trench in South Pacific Ocean, 10,800 meter depth. Mindanao Trench, Philippines, 10,500 meter. Sunda Trench, Indian Ocean, 7,450 meter. Okay, these are some deepest point on the ocean regions of the earth. Okay, now coral reefs and atolls. Okay, unique among ocean fishes, these are organic structures built by millions of coral polyps secreting calcium carbonate skeletons. They thrive in warm, shallow, clear waters between 20 degrees north and 25 degrees south latitude. Okay, one fringing reef attached directly to coastlines like this. Barrier reefs like this separated from land by lagoon. Example: the Great Barrier Reef. Atolls, ring-shaped reefs that enclose a central lagoon. Critical importance, serve as natural barrier protecting coast from erosion and support some of the most diverse marine ecosystems on Earth. Okay, now the Indian Ocean's floor is a complex landscape shaped by active seafloor spreading and continental influence. Okay, Indian Ocean average depth of the Indian Ocean is 3,900 meters. Okay, deepest point, the Sunda Trench. This is the portion, Sunda Trench, at 7,450 meters, a major subduction zone. Dominant ridge, the Carlsberg Ridge, connects to the mid-Indian Ridge, marking a major divergent boundary. Basins divided into major basins like the Arabian Basins and Basin and Bay of Bengal Basin. Continental shelves, notably wide in the Arabian Sea but narrow along the Bay of Bengal coast. Okay, our knowledge of the ocean floor has been built over centuries, driven by scientific curiosity and technological advancement. Ancient marines, early measurements using simple lead line soundings. During 1872-1876, the HMS Challenger expedition laid the foundation of modern oceanography. 20th century, the invention of echo-sounding and sonar allows for the first detailed mapping. Satellite era missions like TOPEX, Poseidon enable large-scale mapping by measuring sea surface height. The future, the Seabed 2030 project aims to create a complete map of the entire ocean floor by 2030. Okay, the shape and structure of the ocean floor is not a static landscape. It is an active and vital component of Earth's physical geography, profoundly influencing the worlds we see and experience every day. Okay, marine resources dictates the location of petroleum, natural gas, and mineral deposits. Marine ecology controls biodiversity hotspots, fishing grounds, and coral reef distribution. Plate tectonics provides the primary evidence for crustal movement, earthquakes, and volcanic activity. Navigation and commerce influence shipping routes, undersea cable paths, and port construction. Climate regulation diverse major ocean currents and affects the global heat balance. Okay, that's all for today. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.